Well, everybody, welcome to lesson 5, where we're going to talk about insulin resistance. This is going to be a really fun and exciting lesson. We're going to talk about the consequences of type 2 diabetes, and these are the number of things you will be seeing this in your clients as you move through your career. So it's important to have a good understanding as how they develop. And so make sure that there's going to be, in this lesson, there's a lot of pathways to make sure that you spend the quality time in practicing these, making sure you put those pathways in your own words, also do the thinking review questions, and there's also practice on Blackboard as well for you to put the pathways in proper order. So there's plenty of practice, but it's going to take a lot of time, a lot of effort, but you're going to learn a lot of good information from this lesson. So the first thing to remember is, in this lesson, is we're going to talk a lot about the role of obesity and its effect on adipose tissue insulin resistance. That tends to be the hallmark of a lot of these conditions associated with type 2 diabetes, and it really sets things into motion. Well, first, here is what happens with adipose tissue, with the needs of someone who when someone has obesity, they tend to store their adipose tissue, their triglycerides, and their fatty acids in the adipose tissue, and it reduces the amount of fatty acids in the blood. However, when these tissues need energy via triglycerides, the adipose tissue will be broken down, and those free fatty acids will be secreted in the blood, and they'll go to the various tissues of the body to be used by those tissues for energy. So that's what should happen. So again, fatty acids are liberated or removed from adipose tissue, circulate to the tissues, and then the tissues use those for energy. However, in someone who starts to develop obesity, over time, their adipose tissue can become what's called insulin resistant. And if you think back to lesson 4, when we talked about the role of insulin in a healthy individual, insulin is supposed to cause the adipose tissue to take up those fatty acids and triglycerides from the blood and store them in the adipose tissue. However, in insulin resistance of the adipose tissue, that does not occur. Instead, those free fatty acids and triglycerides are not taken up by the tissue, but instead they're not taken up by the adipose tissue, but remain in the blood. At the same time, the insulin is not preventing the adipose tissue from breaking down. So insulin usually tells the adipose tissue, don't break down. We have plenty of energy in the blood, so you don't need to break down. However, with insulin resistance, the adipose tissue will break down because insulin is no longer telling it to stop. And therefore, you have increased secretion of triglycerides and fatty acids from the adipose tissue into the blood. At the same time, because you have a decreased uptake of fatty acids and triglycerides into the adipose tissue because of insulin resistance, they stay in the blood as well. As a result, you have an increased amount of fatty acids and triglycerides circulating in the blood. Well, those triglycerides and fatty acids have to go somewhere. And what they end up doing is they end up going to the various tissues of the body, as depicted here. So when you have these little dots here, these little yellow dots indicate triglycerides and fats that have accumulated in these tissues. Well, fat that is accumulated outside of adipose tissue is what's called ectopic fat. ECTOPIC, ectopic fat. And ectopic fat is fat that is stored outside of adipose tissue. And we're going to learn through lesson 5 that all this fat that's stored outside of the adipose tissue will start to affect the normal metabolic pathways leading to insulin resistance and type 2 diabetes and their ramifications and diseases associated with them. So it's a very, very important lesson 5 that we're going to be talking about. Here is the first pathway. This is kind of an overview of pathway. You do not need to memorize this. Do not spend your time memorizing every step, even though I've outlined these steps here in the subsequent slides that you have in your notes. This just helps with explanation. Okay? But again, you do not need to memorize this. However, what I would recommend that you do is you can refer back to these slides, this slide, as an overview or big picture of what we're going to be talking about in lesson number 5. Because that's what this really is. And then we're going to talk about each of these different tissues throughout this lesson. So all of this is you're going to see these slides here with the ordering, and then you have the abbreviations of what they mean down here in terms of some of these abbreviations. To start off, we have adipose tissue insulin resistant due to obesity. You're going to see this time and time again throughout this lesson, and how adipose tissue insulin resistance will cause an increase in what's called lipolysis. Lipolysis is just a fancy word for fat breakdown or triglyceride breakdown. So, as we've talked about before, adipose tissue becomes insulin resistant. Insulin no longer tells the adipose tissue to store triglycerides and fat, and it doesn't prevent the breakdown. So as adipose tissue becomes insulin resistant, it no longer recognizes insulin, and therefore the adipose tissue is saying, I don't see any insulin around, so I'm going to start breaking myself down. And that's called lipolysis or triglyceride breakdown. So lipolysis is just an increase in fat breakdown, and that's going to release triglycerides and free fatty acids into the blood. At the same time, you have inflammatory adipocytokines, which are cytokines. We've talked about TNF-alpha, IL-1, IL-6. These are just cytokines that are produced by the adipocyte. And finally, you have a decrease in the protein hormone called adiponectin. Adiponectin is one of the few hormones that are healthy for us produced by the adipose tissue. And adiponectin, in this next slide here, is a protein, again, produced and secreted exclusively by adipocytes, fat cells. And adiponectin is an anti-inflammatory protein that prevents that on the walls of blood vessels. So it really prevents the damaging effects of inflammation on the walls of the capillaries, the blood cells, the blood vessels throughout the entire body. Interesting, high blood levels of adiponectin are associated with a reduced risk of a heart attack. So a higher level of adiponectin, the lower the risk of heart attack. However, in contrast, low levels of adiponectin are found in people with obese who are also at a high risk of heart disease. So the lower the level of adiponectin, the higher the risk of heart attack. So people who have insulin resistance have a low level of adiponectin, but an increased risk of cardiovascular disease and heart attack. Well, this all happens, a decrease in adiponectin, increased inflammatory adipocyte cytokines, and increased lipolysis, all are going to occur because of adipose tissue insulin resistance. So if someone starts to suffer from obesity, they start to gain weight, their adipose tissue becomes insulin resistant. So what happens is those free fatty acids and triglycerides have to go somewhere. They can't go to the adipose tissue. So this ectopic fat causes some lipotoxicity to develop in various tissue, and various things start to develop, negative things start to happen in the tissue. So keep in mind that a number of these things in the skeletal muscle, or liver, or pancreas could happen in any order, but for teaching you got to pick a particular order and go with it. So just know though that there's not a particular order that these processes that we're going to talk about happen necessarily. They can happen in any order, but for teaching we pick an order and then we move forward with it. So the first thing that we're going to talk about is what happens with that ectopic fat that gets stored in the skeletal muscle. Now, ectopic fat stored in the skeletal muscle is called intramyocellular triglyceride. Intramyocellular triglyceride. It's abbreviated IMTG. And basically that's ectopic fat. That's a fancy term for ectopic fat stored in skeletal muscle. Well, when this ectopic fat gets stored in the skeletal muscle, it's going to cause an increased amount of inflammatory pathways to be activated. junk, NF-fat kappa B, TLR4, all these are inflammatory proteins that activate pathways that can cause damage to the tissue. You also have toxic lipid metabolites, so a lot of byproducts of that ectopic fat can start to accumulate in the tissue as well, causing inflammation. Well, this inflammation and lipid metabolites are going to cause insulin resistance at the skeletal muscle. So the skeletal muscle no longer is taking up glucose in response to insulin. As a result, the pancreas must release an increased amount of insulin in order to get that glucose into the skeletal muscle. But as we learned in lesson 4, this is going to start to fatigue the pancreas out if left untreated. This leads to hyperinsulinemia. At the same time, these increased free fatty acids can accumulate in the pancreas, which can cause the pancreas to release more insulin, causing it to hyperinsulinemia, to work harder. At the same time, adipose tissue insulin resistance can cause an accumulation of excess triglyceride in the liver. Increased amount of triglyceride in the liver is called NAFLD, which stands for non-alcoholic fatty liver disease. And that means that when you're NAFLD means that 5% or more of the liver contains triglycerides. And we're going to find out later that people with NAFLD can have almost up to 50% of their liver could be triglyceride. That's an astounding amount. While left untreated, that NAFLD in some individuals can develop into NASH, non-alcoholic steatohepatitis, which basically means fat plus inflammation. Well, these two combined, individually NAFLD or NASH, can cause insulin resistance in the liver itself. Well, when you have insulin resistance in the liver, that's going to cause the pancreas to secrete more insulin in order to get glucose into the liver, and also to suppress glucose from being secreted by the liver. That can lead to hyperinsulinemia again. However, if left untreated and the liver becomes more and more insulin resistant, you have an increase in what's called hepatic glucose production. Hepatic glucose production simply means that the liver no longer recognizes insulin, and no longer will insulin suppress the liver's ability to secrete glucose into the blood, leading to hyperglycemia. So you have a continuous rise in blood sugar. Well, at the same time, because of an increased amount of triglycerides that are accumulating in the liver, that excess triglycerides are going to be secreted out into the blood via VLDL triglycerides, something we learned in lesson number 3. So what happens is the liver receives that excess triglycerides, and the liver says, you know what, I'm going to do something with this. I'm going to make and secrete VLDL triglycerides into the blood. Well, because of an inflammatory state in the body, you have an increase in that protein called CETP, cholesterol ester transfer protein. Well, CETP, as we learned previously, it causes a decrease in the good HDL, but an increase in the small dense LDL. Well, and we're going to learn more about small dense LDL later, but this is going to lead to atherogenic and dyslipidemia. Atherogenesis, again, is that plaque buildup, which we learned in lesson number 2, and also free fatty acids can also contribute to atherogenesis, all of which can lead to cardiovascular disease. So these 12 steps is just an overview of what we're going to talk about in lesson number 5. Again, you don't need to spend time memorizing each of these steps. We're going to talk individually about what's happening in the skeletal muscle and what's happening here in the liver, and also with the dyslipidemia. Just refer back to this slide in your notes as we go along, and especially at the end, to help bring things together so you have a big picture view. So again, here's just the words, the step-by-step of that slide that you can review in your notes. So what does this all lead to, and what we're going to talk about in this lesson is we're going to talk about individually now skeletal muscle insulin resistance, hepatic or liver insulin resistance and dyslipidemia, visceral adiposity, non-alcoholic fatty liver disease, and also finally finish with glycation. So these are the items that we're going to talk about throughout lesson 5, and I'll post a video of each of these sections so you have a way to review. Also, each of these are going to have a practice on Blackboard to put these pathways in proper order, as well as thinking review questions that you'll be able to then practice and make sure that you have a good understanding and preparation for the exam. So again, take a moment, look over this introduction to lesson 5 before we now move forward with these different features of type 2 diabetes.